Hi, thank you for viewing this tutorial on the motion simulation using augmented reality and the Merge Cube. My name is David Rosegran and I provided the pedagogy and the content behind the simulation while my partners Dr. Gao and Devin Patel at Kennesaw State University provided the simulations, the actual coding of them. So we're going to show you how do you actually use simulation, what are some of the features that you can do with this. So to get things started, once you've downloaded the app, open up the application onto the phone. As you can see, it was made with Unity, and I'm going to kind of walk through some of the features of this. So once we get this in line, we can see sometimes we need to move the simulation around just a little bit, and we can get kind of a nice little picture of the spaceship here. You'll notice on the left, you'll see displacement, velocity, acceleration, and DVA on the bottom. This gives you real-time data collection as well as different graphs, which we'll get to in a second. But you also have, you notice, the red, green, and blue, both on the select side as well as in the simulation. So when I click on, let's say, blue, it brings up a new icon. It has here force velocity, force in newtons, force delay, and force duration. So the initial velocity allows me to change what I want the spaceship to be moving at before anything happens. The force is how large of a force is going to be exerted by the rockets. The force delay is how long do I want to wait before the rockets actually turn on. And the duration is how long are the rockets going to be on for. So I'm going to pick an initial velocity of 1 meter per second. And then I'm going to pick a force of, let's go with 2 newtons, but I want to wait 2 seconds before the rockets turn on, but I want the rockets on for 2 seconds. So once I get my value set, I hit back, and now I hit start. So you can see the yellow arrow here is showing the motion of the object, and the arrow that was here under active forces showed you what the direction of the active forces were. Now when I stop the simulation, I can go back and I can click on displacement, and what happens is I have X, Y, and Z axis. Well, since my motion was all along the Z axis, I click on Z and I get a position versus time graph. If I go back, I can hit velocity and I get a velocity versus time graph, and then I go back and I can also get an acceleration versus time graph. Now, I want to make this a little bit more complicated because I can do some kind of fun type of stuff with the motions. So I'm going to go back to the blue vector, and I'm going to change out the force delay. I'm going to make it 1 second, and I'm going to have it go for 3 seconds. And when I go back, I can now also, if you notice, you have these 3 arrows that are darkened in. When I click on this one, and notice it says backwards. So I can put in multiple activities. So this time I'm going to want to wait 4 seconds because that will take into account the initial 1 second as well as the 3 seconds of the rockets being on. And I'm going to have this rocket on now for 3 seconds. And I'm going to have it be a fairly little bit larger. So I'm going to put the force to 4 newtons. So I go back and I hit start, and again it's moving 0, and now the rockets turn on. And now you notice the rockets go the other way and the direction of the motion changes. So when I stop it now, and now I graph my velocity versus time, you can see how 0 velocity, positive velocity, and now the rockets move on, and you can see how it's sloping down. So this is just a little sample of what can be done with this particular simulation. I hope you enjoyed it, and I look forward to hearing what you do with it in your classroom.